Section 6.1, Introduction to Factoring. So the basic question is, first, what is factoring? To factor a polynomial is to write the polynomial as a product of other polynomials. Just like to factor a number was to write the number as a product of usually smaller numbers. So for example, 9x squared plus 12x can be written in factored form as 3x times 3x plus 4. X squared plus 5x plus 6 can be written in factored form as x plus 2 times x plus 3. And we can verify both of these by multiplying them back out. If we, on this, use the distributive property, 3x times 3x plus 3x times 4 certainly does give us 9x squared plus 12x. And similarly here, if we use that FOIL idea, x by x is x squared, x by 3 is 3x, 2 by x is 2x, and 2 by 3 is 6, and those combine, the middle terms they combine, 2x squared plus 5x plus 6. So these are the polynomials, right? Polynomial factored form. And so in this first section, we're going to talk about one method, actually two methods that we can use for factoring. So the first method is to factor out what's called a common factor. And in fact, we generally like to factor out what is called the greatest common factor. So we first want to actually figure out what is the greatest common factor. And to do that, what I like to do is for each term, write its factorization. So 6x to the fourth is 2 times 3 times x to the fourth. 9x squared is 3 times x squared. Now, we say to ourselves, what is in common between both of these terms? Well, the 3 is in common, and x is in common, but how much x? Well, if we were to actually expand those, we would see that the x to the fourth is, an x times x times x times x. And of course, the x squared is x times x. And we say, well, how much is in common? 2 of them are in common. All right, and so then what we can generally say is, if we have variables, we choose the one with the smaller exponent in this situation. So then what we would say is the greatest common factor would be 3x squared. And so then what we would do is we would want to write this, the 6x to the fourth plus 9x squared, we would want to write that as 3x squared times something, some quantity. And basically what we're going to do here is apply the distributive property backwards. 3x squared times what gives me 6x to the fourth? Well, 3 times 2 gives me the 6, and x squared times x squared gives me the x to the fourth, plus 3x squared times what gives me 9x squared? Well, I just need a 3 here. And actually, if you go back to the factorizations, and you say, well, what was left over in the 6x to the fourth? A 2 and an x squared. What was left over in the 9x squared? What wasn't circled? The 3. All right, so I'll do one more. Then I'll give you a chance to try some on your own. All right, so let's find the greatest. We're asked to factor 5x to the fourth minus 15x cubed minus 10x squared. All right, so let me go ahead and write these out. Let's see, the 5x to the fourth is simply 5 times x times x times x times x. The 15x cubed is 3 times 5 times x times x times x, and the 10x squared is 2 times 5 times x times x. All right, so now we must find something in common with all three. The 5 is in common with all three, and 2 x's are in common among all three. So then the greatest common factor, the GCF, would be 5x squared. So I would write this as 5x squared times some quantity, and it's going to have the same number of terms inside the quantity as were in the original expression. So let's see, 5x squared times, all I need is an x squared for the first term to get back to the 5x to the fourth. 5x squared times 3x, right? Look at what was left over, x squared, 3x, all right, and then a minus 5x squared times 2 would give me the 10x squared. All right, so now if you'd like, you can try several on your own. It would be a great time to pause. All right, identifying the GCF. All right, 10y squared would be 2 times 5 times y, and the second term would be 2 times y. So the GCF, well, would have a 2 in it, and would have a y in it. So the GCF is 2y. So then I would have 2y times 5y plus what? 2y times what gives 2y? Well, 2y times 1 gives 2y. So that's something to be careful about. Remember that if you're factoring using this method, that what's inside the quantity must have the same number of terms as the original expression. All right, finding the GCF for the second exercise. Let's see, 12 would be 2 times 2 times 3 times z by z by z. 8z squared would be 2 times 2 times 2 by z, and the 4z would be 2 times 2 times z. All right, and what's in common? Certainly the two 2's and a single z. So the GCF would be 4z. So then this is equivalent to 4z times what? 3z squared plus minus 2z, and again plus 1. Be careful of that last term. All right, and on the third exercise, let's see, we'd have 3, and we'd have an r cube and a t cube. I hope we've seen the pattern now. And the 6 is 2 times 3, and we'd have an r to the fourth and a t to the second. So taking the smaller exponents, our GCF would be 3 r cubed t to the second. So 3r cubed t to the second times what? Well, let's see, the 3r cubed is okay. We would need a t to the first power for the first term, and we would need a 2 and an r for the second term. So now let's use that common factor method to lead up to another method. All right, so these three exercises are leading somewhere. All right, so looking at these two terms, x times y and 10 times y, the common factor is y. And so what I can do is I can write this as y times something. I can write it as y times x minus 10. And we can clearly check this by distributing it back out. We would see that we would get the original expression. In the second exercise, the common factor let's see. Well, they aren't exactly numbers or variables, but both of them have this box. So let's just call the common factor box. So then we would have box times something. Well, box times x would get me to the first term, minus box times 10 would get me to the second term. I know it looks kind of strange, but there's a point to this. And we look at this third expression, we say to ourselves, well, what's the common factor here? Here we have x times x plus 12 minus 10 times x plus 12. What's in common among these two terms? What's in the box in this case? The common factor is x plus 12. And so I can write this as x plus 12 times something. Well, x plus 12 times x would get me the first term, minus x plus 12 times 10 would get me the second term. So notice that when we have this, sort of a strange looking form, but when we see a binomial, a common binomial factor, it can still be a factor. And just like with the other exercises, we factor it out and multiply it by whatever's left over. So if we had 5x times 3x minus 2 plus 2 times 3x minus 2, the common factor is the quantity 3x minus 2. So I can write this as 3x minus 2 times what? Well, we would need a 5x, and we would need a plus 2. 5x plus 2, those go to the second factor. Try the remaining exercise on your own. The common factor would be x plus 3. So I can write this expression as x plus 3 times what's remaining. Ooh, that one's tricky. There's a 1 there, even though it's not showing. X plus 3 times 8x squared plus 1. This technique leads us to something called factoring by grouping. And so these examples are going to be very useful in the next slide. All right, so let's say we had this expression, 15z cubed minus 5z squared plus 6z minus 2. The first thing that we always check whenever we see the instruction factor, first thing that we want to check is there a common factor? So we look over them and, you might try and write out the prime factorizations, but there is no common factor among the entire expression. Okay, now let's introduce a new technique. Since there are 4 terms, we're going to use this factoring by grouping. We're going to try this out. And so what I like to do is, I like to look at the first 2 terms. And I sort of underline them. And I say, how would those factor? Do they have a common factor? 15z cubed and 5z squared have a common factor. These have a GCF of 5z squared. So the first 2 terms would factor as 5z squared times 3z minus 1. All right, now I look at the second grouping, the plus 6z minus 2, and say, what is their GCF? Well, 6z and 2, the common factor there, all I can factor out is a 2. And I'm going to be more specific. I'm going to say it's a positive 2. And basically all I'm going to do is I'm going to take this sign, whatever that sign is, I'm going to put it there. So I'd have plus 2 times what? Well, 2 times 3z would give me 6z, and 2 times negative 1 would give me a negative 2. Now notice that there is a common binomial factor. Now the GCF is 3z minus 1. And so I can write this as 3z minus 1 by 5z squared plus 2. Try the next one on your own. So again, first thing I would ask myself is there a common factor? Again, the answer is no, there is no common factor. So I look over the first grouping. Do they have a common factor? 6x squared. So then I would have 6x squared by something. 6x squared by 2x minus 3. Then I look over the second grouping, and the GCF there is 5. I'm going to make it a negative 5. Again, I'm taking the sign on that third term and putting it in front. So I'd write minus 5. Now be careful here. Negative 5 times 2x gets me back to the negative 10x. Negative 5 times a negative 3 would get me back to the positive 15. So now I see a GCF of 2x minus 3. And so I can write this as 2x minus 3 by 6x squared minus 5. All right, here's a couple more for you to try on your own. Now would be a great time to pause. Again, I'll ask myself, does the first one have any common factors? 3 and 12 and 2 and 8, nothing common. They don't all have r present, so I can't factor out an r. All right, so first grouping has a common factor of 3r squared. So 3r squared times r plus 4. The second grouping has a common factor of negative 2. So I'll write minus 2. Negative 2 times r is negative 2r, and negative 2 times a positive 4 is r plus 4. Now I see a common factor here of r plus 4. And so I would factor this as r plus 4 by 3r squared minus 2. Looking at the next example, and again, is there a common factor over the entire expression? There is not. So I look over the first two, and they have a common factor of y squared. So I would have y squared times something, y squared times 2y plus 1. Over the second pair, it doesn't look like I can factor out anything there. Well, when that happens, when it doesn't look like you can factor out anything, remember that you could always, if you really wanted to, you could always factor out a 1. So I'm going to factor out a positive 1 here. And so I'd have plus 1 times 2y plus 1. And there is a common factor of 2y plus 1, so I would write this as 2y plus 1 by y squared plus 1. All right, now I just noticed a typo on this first one here. This shouldn't be a 6x squared, but it should be a 6y to the 4th here. Alright, so I'll do this first one. Now it says factor completely. And remember the first step, what's the first step? Is there a common factor? So, I look over the entire thing here, and it looks like they're all even coefficients, so I can factor out a 2, and they all contain a y. So, yes, in this case, 2y is a common factor for this one. So I will write this first as 2y times, let's see, I'd have 3y cubed minus 12y squared minus y plus 4. Now, I'll look over this and try the grouping idea. These have a common factor of 3y squared. The second grouping has a factor of 1. Wait a second, negative 1. So, I'd have 2y, and I'm going to introduce brackets here just to help distinguish things. I'd have 2y times 3y squared by, let's see, we would have to have a y minus 4, and then a minus 1 times y minus 4. And so then this would factor completely as 2y by y minus 4 by 3y squared minus 1. All right, why don't you try the last one on your own? All right, again, is there a common factor over the entire thing? And I unfortunately just realized another typo. That shouldn't be a 19, but rather an 18. Okay. So I would ask you again to pause and try this again on your own. Alright, so here we do have a common factor of, let's see, 3x squared. So I can write this as 3x squared by 6x to the third plus 9x to the second plus 4x plus 6. Alright, now, looking over the first two terms inside the parentheses, the common factor there is 3x squared. And over the second two terms, the common factor is a positive 2. So I would now have 3x squared, and again I'll use brackets here to help distinguish things. I'd have 3x squared by 3x squared times, I'm sorry, let me go back and do the colors correctly here. 3x squared by 2x plus 3, and then a plus 2 by 2x plus 3. And so I see the common factor now of 2x plus 3, so I can write this as 3x squared by 2x plus 3 by 3x squared plus 2.